Hello everyone. In this video, we're going to talk about Kubernetes controllers. So Kubernetes controllers operate a lot like the control loops we talked about before. So controllers run indefinitely and they compare the actual state of a microservice with the desired state. And they make adjustments so that the microservice converges to the desired state. One property of Kubernetes controllers is that they are based on events. So the controller doesn't ask for the state of the system periodically. As much as possible, it just waits passively for updates to the state of the system. So here we see that the resource monitor is more closely attached to the microservice. So the resource monitor is looking at the CPU utilization of the microservice all the time locally. And whenever the resource monitor sees that the CPU utilization has changed significantly, it will generate an event and it will send this event to the autoscaler. Now the autoscaler will get this event and it will decide what to do. It might decide to scale out, scale in, or do nothing. But the main difference for the autoscaler is that it doesn't need to poll the state of the microservice periodically. It waits passively and only needs to act when there's a change to the state. So this not only reduces the load on the autoscaler, but also allows for quicker responses, because as soon as the autoscaler gets the event or any controller gets an event, it can react immediately. It doesn't need to wait for the next cycle to get the new state of the system and then see that the state has changed. It gets the event and can respond immediately. So Kubernetes has many controllers built in. For example, Kubernetes has the node controller, which is responsible for noticing and responding when nodes fail. Here we have the specification for a deployment, and it's a declarative interface. So we say what our deployment is about. So this is an Nginx deployment, it's like a web server, and we state the number of replicas that we want. So this is the number of instances that we run for this container. And it says 3 over here. So when this deployment starts, Kubernetes will spawn 3 instances, and if one of them fail, then the node controller will get a notification about this failure and we will start a new instance so that we get 3 instances all the time. So this controller is built in. There's also a job controller that takes care of running one-off tasks. And it makes sure that these tasks run to completion. So if one of these jobs fail, then they will be restarted by the job controller. There's also the endpoints controller, which is in charge of naming and discovery. That's one of the services for orchestration that we saw in chapter 10. And there's also a service and account token controllers so that people can create accounts and manage API tokens. And we can define our own resources and controllers if we want to create new abstractions within Kubernetes. So let's have a look at the default configuration for the auto-scaling controller in Kubernetes. So the default configuration is this one shown here on the right. So the autoscaler is in charge of scaling down our microservice when load is low and scaling up when load is high. So one of the things that we saw that control loops need is a delay and something to deal with hysteresis. So the Kubernetes autoscaler does have knobs that we can use to control how it deals with delay and hysteresis. So one such parameter is the stabilization window. So here we see that when the system is scaling down, the stabilization window is 300 seconds. So the autoscaler would take a decision to likely reduce the number of instances, and then it will wait 5 minutes until it reduces the number of instances again. And this will allow the system to stabilize. There's also a period between consecutive changes to the number of instances. So when we're scaling down, we check whether we want to decrease the number of instances every 15 seconds. And the same thing when we are scaling up, we check whether we want to increase the number of instances every 15 seconds. And the autoscaler also has mechanisms to allow us to control the intensity of the action that it takes. So here it allows us to control how many instances we're going to remove when scaling down and how many instances we're going to increase when scaling up. So here, for example, when we decide to scale up, we can create up to 4 pods. When we are scaling down, we might decide to scale down up to 100% of the number of instances that we have. So we might go down to the minimum number of instances that we specify in our deployment. And this equation over here is the equation that the Kubernetes autoscaler uses to compute the number of instances that a microservice should have. Number of instances that the microservice should have, like the new number of instances, is equal to the old number of instances. So the new number of instances is a function of the old number of instances. It's a relative change. And the relative change is given by this multiplication factor over here, which is just the current state of the system divided by the desired state. So if the current state of the system, CPU utilization, for example, is higher than the target CPU utilization, then this ratio will be larger than 1, and we're going to create instances. So instances new will be larger than instances old, and vice versa. If the current CPU utilization is lower than the desired state, then this ratio will be less than 1, and the new number of instances might be lower than the current number of instances.